Good morning. It's only 3 people. I'm fine with that. I just need at least five. I actually fixed my delay too, so it's like only 5 seconds. Um, no. I want to see work. If you want, however you want to show me work, you can show me. Like if you want to edit a PDF using an Apple Pen, you can do that. You can, if you want to take a picture of you doing the work on like loosely for something, you can do that too. And then you can upload it and submit it for the for the assignment. However you want to do it. But I do want to see some work though. I don't care. Yeah, I do want to see some work. And in some cases, it's more intensive, I guess, than actual. Can you hear me? Okay. I didn't grade any assignments yet. They're not even due. Oh man, the delay is really low. I think it's like 2 second delay. Yeah, and I didn't grade the one from yesterday. If you need me to help you do the homework, I'll do it right now. I'll help you do the homework. The actual lesson doesn't start until 12:30, but I'm down to help you do yesterday's homework. I mean, it's due in 1 hour. I will do today's homework. I do the homework at the end. I mean, I don't do all the questions. I do some and then do do today's homework right now. We haven't even started a lesson. No, I'm not gonna do the homework right now. All right, nah, I'm just yeah, I want to start at 12:30. I think every teacher yesterday every teacher yesterday just complained about how many emails they got because everyone was just spamming those teachers about how to log into Google Classrooms, how do I do this, how do I do that. Because one o'clock is like the best. No, no, Angie, you don't have to write the question. The only thing I really care about is I want to see the work. Yeah, I'm actually gonna keep this live stream up for until 3 o'clock in case anyone needs to ask me questions. I don't want to get emails. I get enough emails from the Google Classroom comments, and I'm good. I'd rather people ask me questions for the stream. There's also a decrease. Also, because every teacher got noticed like less people were asking them stuff. They're also noticing less participation today. Whereas yesterday there were a lot of people, and then today teachers noticed that there aren't a lot of people anymore. What's up, Alicia? Mr. Malia says hi. All right. I know one other teacher spent like 3 hours responding to emails because students did not know how to troubleshoot problems. Actually, a lot of you guys have problems with if you're logged into another Gmail account and then you try opening the assignment, what's going to happen is that it's going to give you no classes found because you're logged into your other Gmail account. And you have to use your school email account to actually see the classroom. And so that's what a lot of students had problems with. And it kind of drove all the teachers crazy. Great, I haven't gone out in a long time. I just play games all day. How's your quarantine? Wait, Alicia, what's what's Malia streaming on? No, I don't play Fortnite. I don't play kid games. Google Meet. A lot of teachers are using that. The thing about that is, can you voice chat with him too using Google Meet? Yeah, I'm good. I don't want to hear your voices. I definitely don't want to see you guys either. I'm answering your questions right now pretty fast, to be honest. Oh, you mean typing? Yeah, you mean typing. I'm fine with this. No, I'm good. I'm good. I don't want to use Google Meet. I have to be different. Can't be the same. Can't be like all the other teachers. Honestly, I really though, I don't really want to see your faces, and I don't want to see you guys talk. Cause if all you are interrupting me, that's not it's not fun. I take that back. Yeah, but I don't have to I don't have to like click a button to mute you guys. If I don't wanna, well, Malia's classes are different. Melia, I keep forgetting. I keep calling it pronouncing it wrong. Melia, it's Melia, not Malia. Melia. What time does he stream at? Who the hell is wannabe loser? I'm curious. Yeah, yeah. What time does Melia stream at? It goes from 9 to 12. Oh man, 9 to 12. Oh, okay. I get it. 9 to 12, 3 hours. I don't think I can last that long with you guys. 45 minutes is enough. It doesn't just sound. It doesn't sound long. It is long. It's a very long time. 3 hours is a very long time. It's a very long duration. You have to turn on notifications. It's like a setting. Are you sure you don't get my notifications? I'm pretty sure. Hold on. No, I don't see anything. It should get notification. Does anyone else get notifications? Yeah, I think it's just you, Arissa. Probably. Or you selectively ignore notifications from my class in your email. Like your brain just ignores anything related to physics. Oh, okay, I see. I think I think I selectively ignore you two in class. I'm not sure about that. I think it's I subconsciously do that. You can yell. Oh, you can tell. Hmm. Well, I ignore the fact that you're on your phone. No, no, no. That's definitely not true. That's definitely not true. That's definitely not true. Oh god, that's please. I'm gonna have to delete this comment. Gonna delete that. Hopefully, no one screenshotted that. I don't ignore you, Arsa. I am with 6 students in this watching right now. It's impossible to ignore all your questions. I want to go do a lot of things too, but I'm here. Yeah, I'll start in 14 minutes. Honestly, with this class, with this the amount of people watching, I can actually answer a lot of questions. I can go really slow. What was with that comment? Wanna be losers, Penelope. What's with the Tesla thing? Like, what was the comment you made earlier? And your mom was mad or something? My Tesla's parked right outside right now. I even drive it. Where am I gonna drive it to? Where am I going? There's nowhere to go. No, I'm not gonna. My life is not that fun, Angie. I don't know about your life during a quarantine, but my life isn't that fun. It's me playing games with friends. That's my quarantine life. That's it. That yeah, that might be a revelation to you, but I do. That reminds me, I have to start calling parents soon. We're actually teachers are mandated to every student that who didn't do any homework, I have to call because that's what they're making us do. I have to call parents. If I look at it quickly right now, I think I have to call 40 parents. I think I do. What's up, Joshua? Like I'm fine if they don't watch the stream, but not doing the homework. There's like a 10-minute condensed video of yeah, there's a 10-minute video of just the the topic, the lesson I put up. If you can't watch 10 minutes, then it's fine if you don't watch it live, but not being able to watch the 10-minute lesson, it's pretty bad. All right, we're back. No, I'm gonna start in 10 minutes. We're back. All right, I'll start. Just turn off the music. Yeah, yeah. Let's start. Let's start. Let's start. Let's start. Let's start. Actually, just can't you plug your phone in? You can plug your phone in, right? Yeah, I told you, Alicia. It's you have these students just giving up. No, I didn't assign 7B yet. I'm assigning. I schedule it to show up in 1 o'clock. I've actually scheduled all your previous homeworks. Yeah, I'm definitely starting 12:30. I scheduled all your previous. I'm all your future homeworks. I scheduled them all. They should show up at 1 each day. So you're gonna get one homework each day. Do your other teachers make you do it like a do now assignment, like a do now assignment, stuff like that? I know some other teachers doing that. Joshua, I've answered this question multiple times. Yeah, I think I've answered this question multiple times. I mean, I'm making you do the homework daily. I'm just not giving you classwork to do. Actually, I've never given you classwork. You feel like it's too much? Well, maybe if you don't spend 3 hours watching Melia, you might have more time. Yeah, I mean, yeah, Joshua. I'm sorry if I was being passive aggressive. I apologize. It's really hard for me to not be passive aggressive. But yeah, I don't want you to do I don't want you to do on Castling because I don't see your work. If you want to edit the PDF I attach and using an Apple Pen or something, or you want to take a picture of a loose leaf which will work on it, or you can use a Google Doc, you can. Like as long as I see the work, then you're good. The rubric is up there as well. But yeah. I apologize if I'm being passive aggressive. When you get asked the same questions multiple times, you can't just. It gets to you. Why would she be? Well, what question? There was no questions being asked. There were no questions being asked. You don't know what passive aggressive being sounds like? Um, okay, here's an example from one of the other teachers being passive aggressive to everyone else. So teachers have to call in to announce that if they're sick, they're not coming in. And so this call log was full. So there was an email sent out. The number for teachers calling in sick is full. If you are calling in sick, if you're not coming to school, please email this email. Please reply to this email. One person did reply all, and then Alamarie, AP Alamarie, responded, "Thanks for letting everyone know." That's passive aggressive because obviously the person didn't need to reply all. He only needed to reply to one person, not every single teacher, and letting every single teacher in the building also know he'd be absent that day. Yeah, I am there every single day. There's no reason calling sick. Of course, I'd be there every day. I'd be here every day too. I don't need a break. This is my break. This is my break. I don't know what you're talking about. Hello, Tira. If I miss a day, you guys miss a day of instruction. Anyway, I'm getting enough of a break. This is enough of a break for me. Oh man. I'm not one of the other living environment teachers. Well, before this whole thing happened, he planned to be off a single day every week. Like one week he'd be going on a trip, so he'd be chaperoning, so he'd miss an entire day. Another day he'd be going to PD. Like he had like a day planned every week that he'd be off or not teach. But I can't do that. I need to get you prepare you guys for the regions. Now, if you want to take a break from my class, Arissa, I appreciate that. They most likely will. I don't know. It looks like this quarantine thing is gonna last for a long time. So the April 20th is like a placeholder, but I think it's gonna last longer. But don't get your hopes up. Yeah, don't get your hopes up that it's gonna last longer. I want it. I don't know. If it lasts longer than April 20th, then you're most likely not taking. Actually, don't take my word for it. Don't quote me because I can't be wrong. But that's just my opinion. Like my opinion is that if you don't come back to school after spring break, then yeah, you probably won't be taking the regions. I'm just disappointed that I'm just disappointed that I won't get my physics data pass rate for my regions. I don't miss school. I miss you guys. Correction. I miss you guys. I miss my physics students. I don't miss anyone else. Yeah, that's a good correction. I saved myself. Imagine having to say that because you never told another person you've missed them, Joshua. Another another male you've missed them. I miss a lot of my friends. I don't know about you. All right, let's start. Let us start. Let us start. Let us start. Let's start. Oh, let me disable the overlay. Well, it's not really an overlay. It's just the text. All right, let's get started. All right, all right. So yesterday I introduced I think I talked about simple circuits. I talked about it briefly, but I didn't really go too in depth. Yesterday we mainly talked about electricity. Well, whether electrons are moving electrons, and so that generates an electric current. So any electricity you see, any lightning you see in the sky, that's moving electrons. Electricity is basically moving electrons. Now, how do electrons move? How do we direct that movement? We're going to use circuits. And so you kind of on the left-hand image right here, on the left image right here, you kind of see a circuit board. And now we have these. If you guys didn't go on break, we would have used these circuit boards on we would have used these circuit boards on the in lab. Mohammed, you're being sarcastic right now. Don't even start, Mohammed. I don't want to hear you. I don't want to hear you right now. But yeah. On the left-hand side, this is a circuit board. We would have used it if we would have still been in school. Unfortunately, we're probably never going to use this circuit boards because probably not coming back. But we would have used this. We would have played with it. And so electrons move through these circuits. Electrons move through these circuits and they power objects. All right. And so again, you see a simple circuit on the right-hand side. Right, you see this circuit on the right-hand side. And you see a battery on the bottom right here. All right, and so this battery, you see the electrons move from the negative side, and they go along this wire, along the circuit, and they move to the positive side. And so that's how electrons are transferred. That's how everything is powered. That's where electricity comes from. That's electricity is basically electrons, moving electrons. And so that's why everything in the world works. And you see the pole lines outside on the street, those are carrying electricity, carrying electrons. Now, yes, we also talked about uh current, and I said that current. I said that current. I can't read comments and talk at the same. Current is the amount of electrons that move over time. Okay, so how fast how fast electrons are moving doesn't really matter, but electric current is more about how many electrons move in a duration of time. So in 5 seconds, maybe like 1 million electrons move in 5 seconds over this area, or like 2 million electrons. So that's what electric current is how many electrons are moving through an area at a certain amount of time. Now, we also covered this before we move on. Is everyone okay with electric current? Like before I move on. How's the electric current for everyone? Nope, not good at all. Joshua, did you want a good? Okay, hold on. Uh, here. Do you know what a current is? Water current. So you can kind of think of water current as electrons, an electric current. So how fast this water is moving is basically the water current. So if the water is moving faster, you have a higher water current, right? It's moving faster, that's a higher velocity. And let's say let's now transfer this analogy to electric current. So electric current, if you have a high electric current, you can say that the electrons are moving much faster. Okay, so in this water right now, let's see. Hmm, sure, perfect. So here in this GIF, you see a high water current, right? So if you have a high water current, you see that this water is moving at a very fast pace. And if you have a high electric current, you can kind of make that same analogy. If you have a high electric current, all the electrons are moving at a really fast pace as well. How's that analogy, Serena and Joshua and Irissa and Tahira? How is this analogy right now? Make sure you press the live button if you're not to catch up to live. There should only be like a 2 to 5 second delay. It's not like I'm glad you guys like the analogy, but do you understand how that analogy transfers over? So I'll say it once more. So you can think of water current like electric current. So if you have a high water current, you can see that the water moves really fast. And if you have a high electric current, then the electrons are moving really fast. So again, electric current is how much charge moves. No, no, that's not true. That's not true. There's a rest. Electrons are not moving fast. I think they definitely not. Definitely not. The relative velocities, it depends, but electricity is not moving fast. You need something to cause it to move fast, to cause the electrons to move fast. So yeah, well, we need voltage, but we'll talk about voltage later. You do need a force from from something else. Yeah, force. You do need a force, but from what? And we'll talk about it. So again, you can relate water current to electric current. Well, it depends on how fast the water current is, right? So if you have a fast water current, if you have a lot of water, and then you have a lot of high water currents, if you have a lot of electrons, you have a high electric currents. Okay, and so I want you to keep that analogy in mind. Uh, but make sure that if you have any questions about current, just let me know. What's up, Hamza? And Dark Knight Gaming. That's very hmm. But yeah, let's talk about voltage now. It's about voltage, and kind of want you to relate voltage to pressure, not about water velocity now. I want you to relate voltage to pressure, to water pressure. And so I want you to take a look at the top left hand image, right, in the top left hand corner. So high pressure, you can relate high pressure to high voltage. Right, and so if you're thinking of water as electrons, and so if you have a high pressure here, right, you have a lot of them, exerts a lot of pressure. That means you have a lot of electrons and there's a lot of voltage. So you can think of voltage as pressure. And so, well, what's gonna happen if you have a lot of water here? What's gonna happen if you have a lot of water here? You guys can type in chat. This is a very small delay. Are you guys full screening this? Oh, what's happening here? Hmm. All right. That's fine. That's fine. No, okay. That's fine. You guys can full screen this. I'll just explain. All right. So your voltage. Let's think of water as electrons, and I think that's the easiest analogy for you guys, right? That's an analogy a lot of professors use actually. So you can think of water as voltage. I mean, water as electrons. And so when you have one side with a lot of water, and you can see on the top left hand corner right here, if you have a lot of water here, well, what's going to happen is that all this water is going to push over to this side because this side has lower pressure, lower water pressure, and this side has greater water pressure. And so what's going to happen is that the water from this left hand side over here is going to flow through to the lower pressure side. So there's more water here, and that water is going to go to the right hand side. And you can kind of think about it, you can relate this to electrons again. So if you have a lot of electrons on the left hand corner, all these electrons hate each other. They want to get as far away from each other as possible. Okay, all these electrons want to get as far away from each other as possible. So what's going to happen? Well, these electrons are going to flow from the left hand side to the right hand side. So there is a higher voltage here. There are less electrons here, so there's less voltage. There are more electrons here, so there's a higher voltage, higher pressure. And so it's going to travel from a higher voltage side to a lower voltage side. All right. Before I move on, ask me any questions about that. And so we're going to relate that to electric current. Yeah. So the fact that you have a difference in voltage, which is where the definition, where the vocabulary potential difference comes in, right? There's a difference in potential. And so because you have a difference in voltage, that causes an electric current because the higher pressure water is moving to lower pressure, and now you have an electric current. Now you are creating electricity. You are creating electricity now. Right? You're moving these electrons. And this is the force. This is what Arista said before. This is the force that's creating the electricity. It's because these electrons want to get as far away from each other as possible because there's so many of them here that they're going to move to an area with less electrons, less pressure, less voltage. And so that creates electricity. That creates an electric current. And so that's how I'm going to relate voltage to current. All right, I want to move on. If you, let me know if you guys have any questions before I move on. Volts are measured in volts. Voltage, volts. Oh man, very innocent question. What are volts measured in? Ah, you mean that? So volts are measured in ohms over amps. Volts is basically fundamental units. You gotta Google that one. I don't remember off the top of my head. Okay. So now let's move on to resistance. So far we learned about current and voltage, but there's one more key variable at play here, and that's called resistance. So if you move electrons through anything, it's not there's not going to be perfectly moving to the next point. There's always some resistance, whether it be due to material, like something in the atom is preventing it from moving uh, without loss of energy, right? As these electrons move through the circuit, they're gonna hit they're gonna hit stuff. They're gonna lose energy as they move through the circuit. So they're gonna slow down over time, and so that leads to a decrease in voltage, decrease in pressure, so decrease in the speed of electrons. And so resistance, anything that has electrons flowing through it, causes a resistance, causes what we call a resistance. So let's take a look at the circuit right here. Right, as electrons from this battery go from the negative side across this wire, go through the light bulb and lights up the light bulb, powers up the light bulb, there's going to be a resistance from that light bulb slowing the electrons down. So as these electrons are going through this light bulb, the electric current slows down. All right. So they travel slower after they pass through the light bulb, and now the electric current here is slower than the electric current over here. All right. So and we're going to call this resistance. So everything, every material, every object has a resistance associated with it. And I want you to think of it like a dam. If I were to make another analogy here, I would give you like a dam. Well, batteries are let me answer Joshua's question first. Batteries, big batteries, it really depends on how much they can hold, how much kilowatt hours they can hold. Um, when your battery is low percentage, that means there's less electrons, there's less voltage in that battery, right? So there's less electrons in a battery with less percentage. So that means early on, when you're charging it, charging from let's say 20% to 80% goes really fast because you don't have much resistance. There's very low voltage in that battery compared to your 120-volt socket, your charger, right? But as you go from 80% to 100%, what you start noticing is that the charging rate slows down because you have all these electrons packed in the battery now, right? There are not many atoms. Well, there are not many free atoms to hold electrons anymore, right? So there's a greater voltage and so you're not going to charge as fast going from 80 to 100% as you would from 20 to 80%. It's kind of like my Tesla. I actually see this happening in real time when I charge my Tesla because as I go from 20% to 80% charge, I charge really fast. It takes me like 20 minutes to go from 20 to 80%, but from 80% to 100%, that takes me another 20 minutes. So so as you go so as you go to a higher percentage of battery, you it's slower. It's slower to charge. Because again, you have all these electrons already packed and not as many atoms are free to hold electrons. It's also why like the last percentage, last 5% from 95% to 100% takes a really long time. It's almost not even worth it. No, but again, like relating resistance to like a dam. The dam in this picture slows down the rate of flow. So if you're thinking of water as electrons again, right, the dam slows that water down. Even though there's a much higher water level here and there's a much lower water pressure here, this dam right here is slowing the water down. If you were to remove this entire dam, you'd notice that all the water would just go flowing through. All the water would just go flow through, and that would result in a high electric current. But since this dam is here providing a resistance, the electric current slows down, which is needed. Yeah, if there's more electrons, there should be. Well, that goes into voltage. If you have a lot of electrons, they all want to get away from each other. I don't like Google Meet. I don't want to see your faces. Just joking. I That was a joke. I'm sorry. That was a joke. So yeah, again, if there's anything I want you to do, I want you to think of water as electricity. I mean, or rather, electrons. Water is electrons. Yeah. Again, I'm gonna explain this one more time, and I'm gonna go through everything. This high water level here, there's a lot of electrons. There's a high voltage. There's a lot of electrons. So all these electrons want to get as far away from each other as possible. And on this water level right here, there's very little electrons. There's very low pressure, low voltage. So all the electrons over here want to go down here. I'm answering your questions right now. I'm answering you. There's a very low delay for me. And this dam right here is your resistor, right? It could be your light bulb, it could be an appliance, it could be like your computer, your charger, your Nintendo Switch, your PS4, your Xbox. This could be anything. And as you run your electrons through your appliance, through your object, it slows down the electrons. It slows down the electrons. So that's what resistance is. That's what this dam is, right? It's a resistor. It's anything that has electrons flowing through it is causes resistance. And to answer your question before, Roita, I just remembered, yeah, it's basically the electrons are hitting the walls, hitting various atoms, and that's why the electrons slow down. There's less electrons. You can think of less electrons, yeah. There's less of a charge there. You can, but you don't want to. You can remove resistance, but you don't want to because you don't want too fast of an electric current because that's just gonna fry everything. You want there to be some resistance. You don't want electrons moving too fast. You want to slow down your electrons. Because as a result of electrons moving really fast, again, as things move faster and faster, you cause a lot of heat, and so that's gonna burn up. So let's move on. But I do want to move on. But if there are any questions about current, voltage, or resistance, let me know. I also put a note sheet attached as well. So if you want to read all of this, there are notes attached to the homework assignment. Uh, I mean, do I really want to go over the circuit? Sure, I'll go over the circuit. So on the regions questions, they're gonna represent most circuits as this type of diagram. So you see a battery on the bottom. That's what they represent a battery as. And so this long head side It'll show up at 1 o'clock. It'll show up at 1 o'clock, Shane. Everything, all your homework assignments are scheduled to show up at 1 o'clock. Yeah, pretty much. So this battery right here, the long side right here means that's the positive side. So there's less electrons on the positive side. And on the left-hand side, that's the negative side. And so there's a lot of electrons here. And so what's going to happen is that all these electrons are going to move along this wire, along this circuit, and move to the right-hand side. And so they're going to pass through something called a resistor. A resistor is really just any appliance, like any electrical appliance, like a refrigerator, your air conditioner, your computer. So this resistor can be anything. And as it passes through the resistor, it slows down. The electric current slows down. So that's your circuit right here. But we'll learn more about circuits in 3 days. Yeah, 3 days. And this show you like a GIF. Or rather, yeah, I mean, I guess it's a GIF. Uh, I would say that what you're seeing right now is you're seeing electric current passing through the wood. All right. But we'll talk more about that. I just want to show you. So now let's talk about the formulas. The only formula you need. So the formula we're going to be learning today, and you're going to be using to solve problems, is R is equal to V over I. So R is your resistance, V is your voltage, and I is your current. Okay? So R is your resistance, V is your voltage, and I is your current. Yeah, I wanted to do a circuit lab. Yeah, I was planning on doing a lot of circuit lab. No, you can use. You mean this? No, you can't do this. I'm not doing this in lab. You're kidding me. That's not happening. One of you is gonna die. All right, and I don't want that on my. I don't want to go to jail. All right. Actually, that's the only thing. One of you is gonna die. But we are gonna use. If we do come back to the school, we are gonna play with circuit boards. We are gonna play with circuit boards. So the only formula you need is R is equal to V over I. So let's talk about how to solve these practice problems. So number one, again, you're gonna get the homework assignment at 1 o'clock, so in 3 minutes. All right, so let's take a look at number one. So in a simple circuit, a 24 ohm resistor, so your resistance is 24 ohms, is connected to a 6-volt battery. So what is the current in your circuit right here? And so the formula you're going to use is R is equal to V over I. All right, so well, your R is 24, your V is 6, and your I is something, right? That's what we want to find out. So we're gonna get I to the other side. So 24I is equal to 6 divided by 24 divided by 24. Then you're gonna get 25 amps. All right, and you're gonna get 25 amps right here. That's it actually. That's the answer. And all the other practice problems in the sheet is exactly like it. You might have to think for number 5. Yeah, you might have to think for number 5. If you have problems with doing number 5, I'll be here. But that's pretty much the end of this stream. I'll stick around to see if you guys have any questions. And if you guys don't have any questions and if you guys are free, never mind. I don't want you in the stream if you don't have questions. I mean that's a bit mean. That's a bit mean. Uh, I am happy to have you guys in the stream to ask me questions. Please ask me questions if you have questions. But yeah, if you want me to explain something more in depth. No, I was not serious, Irissa. Tesla's. I think most formulas are measured as a rate of something over time, and you get some other random variables. Yeah, to hear it, just ask me questions. Yeah, also the homework assignment should be uploaded already. I'm just eating lunch right now, so just feel free to ask me questions. Um, can I do number two? Don't worry, Iris, I didn't ignore you. Can I do number two? Sure. Actually, do number two with me. Arissa, the formula from yesterday. So Alicia, the formula from yesterday was I is equal to delta Q over T. That was the formula from yesterday. Yeah, stream started at 12:30. But it's okay, Tom. You can just watch. You can just rewatch the stream. But so Arissa, what are the two knowns you have? Today's form is R is equal to V over I. But I think you should not. I think you should try and understand what's going on with the class. What are you talking about, Arissa? Tommy didn't change his profile. That's his normal Gmail account. I'm not ignoring you, bestie. Irissa, tell me what are the nodes in number 2? Kind of. Kind of, Farhan. Yeah, so your vote is 0.40. What else do you have? What's your other known, Irissa? No, I don't like staying home, Farhan. Alright, Irissa. It says in the problem, the first, it says, what is the current in a 100 ohm resistor? So that 100 ohm resistor is your resistance. So R is 100 ohms. And you want to find out what your current is. Alright, so you have your R, you have your V, and number 2 wants you to find out what your I is. And so you can do that, Arista. I believe in you. Fine, I kind of like staying home. I pretty much all I do is play games. Play like Jackbox party games, and other games with my friends. That's it. Who knows? I'm probably playing Jackbox right now. A 5? Hell yeah. Yeah, 5. I, I, I mean, I think 5 is the hardest for you because it's more like a conceptual question, and you guys have problems with conceptual questions. I'm not gonna. I want you to try, Arissa. All right. So it says in the problem, your resistance is 6 ohms, right? And so number 5 says your resistance is 6 ohms. Now, and it says like it's connected to a source of variable potential difference. When the applied voltage, yes, Tommy, when the applied voltage is decreased from 12 volts to 6 volts, the current passing through the resistor is what? So what is this resistance right here? What is this current? What is the current? So if you think about it, and you set up your formula again, so R is 6 and V is 12, and you have I, right? And so I is going to be 2. So that's with a voltage of 6. I mean, voltage of 12. And when you have another voltage applied at 6, you don't have to use, you don't have to plug in anything. You can actually just solve this conceptually, but you don't really need to use numbers. But let's say we want to use numbers. I'm sorry. I apologize. So your I you're gonna get right now is 1 amp. And so that makes sense because if you have less voltage, the speed of the electrons running through the circuit is going to be much slower. So you're going to get a current of 1 amp. So what's going to happen is when you decrease the voltage by half, well, if you decrease the voltage by half, you're going to decrease your current by half too because you're slowing down the rate of electrons, right? There's less voltage, so the electrons are going to travel at a slower speed. I actually don't even care if you get it wrong. I'll tell you if you get it wrong, but I don't take off points if you get it wrong. Yes, Arissa. I I don't know what you're saying, Robita. What do you mean by distribution of energy? All right, Arissa, what do you need help with? You can upload it to the assignment. Attach it. The answer for 5 is C. You're because you're going from 2 amps, right? You're going from 12. So your voltage goes from 12 to a voltage of 6. And that means your I goes from 2 amps to 1 amp. They're the same thing for you. Voltage is potential difference, or voltage, or volts. It's the same thing. Sometimes you'll see voltage referred to as potential difference, because that's really what voltage is. Because your voltage is your difference in water in your electron pressures, in your electric pressure. Yeah. No, I cannot tell you the answers to the rest. Iris, I'll solve them with you. So Arissa, can you tell me the nodes in number 4? I also don't mind these other people, Arissa. It's fine. Just work with me. What are your nodes in number 4? Good. Yeah, R is 10 ohms. What else do you know? Amperes is how you measure current. So you measure current in amperes, which is A. So that's your current. So your current is 1.2. What do you want to find out? You want to find out potential difference. Potential difference is your voltage. All right, that's just another name for it. So you want to find out what V is. Yeah. So you want to find out what your potential difference is. So that's V. The formula is R is equal to V over I. If you look at your notes, you'll see. That's the only formula we learned today. No, I don't have a PS4. I have a PC. No, no, no. Amperes is I. I is measured in electric current. So I is amperes. I is measured in amperes. So I is amperes. Tommy, I would go back to watch because you need to know what the hell voltage is and what resistance is and what a circuit is. Unless you already know. Actually, if you're in robotics, you probably already know a lot about circuits. Amperes are just is electric current. That's basically it's charge over time. The rate of flow of charged particles over time. So that's what amperes is. Named after Ampere. V is your voltage. So V is your voltage. So V is voltage or potential difference. So they're the same exact thing. Yeah, no problem, Arissa. Just let me know. Yeah, it only has 5 questions. Tomorrow's gonna start at like 12:30 again, I guess. Your number 4 doesn't match mine. Your number 4 is just mine. Your number 3 is my number 4. Here, done. All right, you have it's the same number now. It's consistent. What? Irissa? Hold up. All right. Well, I think your music is trash too, Arissa. Really, she's joking. Or is she? Either way, I don't take it seriously. Oh, no, I don't know. I don't know the relationship you two have. I know it was a joke. That's why I didn't take you seriously, Arissa. If I was actually mad, you'd know it. Alright, if I was actually pissed off, you would know it. I don't think there's a time I've actually gotten pissed off teaching you guys. I've been disappointed. Yeah, I know. It's actually, there's still 5 questions. It doesn't matter if the worksheet doesn't have number 3. It's still 5 questions. When was I screaming? What does cap mean? I I'm too old for this. What does cap mean? The cap I know that means lie is spelled KAP, and that's like the Twitch emote. So I know cap. Is that where it originated from? I know cap. I know cap is a lie on Twitch. It's like that emote. Did it come from Twitch or is the does the Twitch emote from cap? Because that's what I was thinking. It's like, is it representative of that emote? You're part of this age group. My name is not Mr. Chen. Woo? You want me to say like a question or it's like a statement, like a affirmative statement? Like woo. Woo? Woo. Woo. You want me like an owl? Woo. Oh yeah, I don't. I can't do it. Woo. All right. Any more questions? Just let me know. For what? What'd you get 0.004 for? Number three? Two. Your R is 100, right, Arissa? Your R is 100, correct? Your V is 0.40, right? It's not 40, it's 0.40. So let's solve this. So R is 100, V is 0.40, and you want to solve for I, so you want to get I on the other side. Ah, okay, okay. Yeah, you do get. Yeah, no, you're right. You got it right. So you divide this by 100 and you get 0.004, and that's amperes though, right? You measure this in amperes. Now, but you see in the choices give you a unit of mA. So you're gonna have to convert this unit into milliamps. Right? You're gonna have to convert amperes into milliamps, and there are in 1 ampere. In 1 ampere, there are 1,000 milliamps. So that's a unit right here. That's a unit. So you're gonna have to multiply this number by 1,000. So 0.004 times 1,000 gives you what, it gives you like 4? Yeah, yeah. 4 milliamps. So the answer is D for number 2. How are we doing, Arissa? I sleep at like 11. All right, I gotta. Yeah, yeah. Yesterday's formula? It's yesterday's formula was this. Tommy, you just got refresh. I don't so great. Right. Uh, nah, I'm good. I'm okay. I'm okay. I'm okay, Arissa. Did you have don't you have another class of one? I thought you had another stream to go to at one. You can watch reruns of it, right? At least, or like a recording. Huh. Well, I would watch their streams. Oh, so there's no recording at all? I mean, you should make the 1 o'clock Google Meets if you can, because at least you can watch a recording of this. I mean, okay. I'm pretty sure on Google Meet you can record the Hangout sessions. I'm sure you can. Mm, then what does your teacher do if students don't show up? Like, I'm sure some students don't show up. There's no way that your teachers get like a full, all your students showing up to the Google Meet. There's no way that happens. If that does happen, then I'm jealous, and I want to learn how they're doing that. I'll be I'm glad you nice. I'm glad you noticed it, Arissa. Good job. See, so you got this. Glad you noticed it by yourself. Now I need to just call parents. The stream ended a long time ago. I'm just having this up to help you guys. If you have any questions, I'll help. But this stream is pretty much over. See ya. Yeah, it's over. It was over at 1. I just stayed to help you guys. Oh, yeah, I'll check. You know, when you take a picture next time, can you like do it from a top-down view instead of a slanted view? This is easier for me. But everything looks fine. Yeah, 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 everything looks fine. Yeah, yeah, yeah. You're good. Because it's just like I'm looking at a slanted view, and that doesn't help me much, if any. Yeah, bye.